Okay, the denominator is not a variable, it's just a number, and that number can't be 0, it's not 0. So this domain is all real numbers. There are no restrictions on this domain. Now, if x were equal to 0, this would be an undefined fraction, so x cannot be equal to 0. And the way we write that, we open up a set, we say all numbers x such that x cannot be equal to 0. Here, x plus 5 cannot be equal to 0. So x cannot be equal to negative 5. So all the numbers x such that x cannot be equal to negative 5. This x cannot be equal to 6. So all the values of x such that x cannot be equal to positive 6. 2x minus 5 cannot be equal to 0. Move this over, so you have 2x cannot be equal to 5, so x cannot be equal to 5 halves. So we open up the set, all the values of x such that x cannot be equal to 5 halves. Now in the future, I'm not going to show this work anymore. It's always the opposite of this and the right number over the left, so positive 5 over 2. So x cannot be equal to positive 2 over 3. So all the values of x such that x cannot be equal to positive 2 over 3. There's no value for x that when after squaring it and adding 10 will be equal to 0, because x squared can never be a negative number, and we need this to be equal to negative 10 in order for this to be 0. So this is all real numbers for the solution, because there is no number of x that could work to make this a negative 10. Therefore, x could be any number. Okay, I'm going to factor this. I'm looking for factors of 20 that add up to negative 7. So in my denominator, I have x minus 7 and x minus 4. So this is all the values of x such that x cannot be equal to positive 7 and positive 4. Okay, I'm going to factor this. I'm trying to get to 8, so I'm going to try 2 and 2 to begin with instead of 4 and 1. And I'll do a minus 3 minus 1. So my outer is negative 2, the inner is negative 6, and negative 2 and negative 6 really do add up to this, and these multiply to that. So this is all the values of x such that x cannot be equal to positive 3 over 2 and positive 1 over 2. I need to factor this. First thing I'm going to do is take out a GCF. So I only care about the denominator. So I have 4x squared plus 4x minus 15. Now, I don't know for sure what I have, but I'm going to try 2 and 2. And I might have to go back and change it to 4 and 1. But I'm going to try, instead of 1 and 15, I'm going to try 5 and 3. So let's see. I'll do a positive 5 and a negative 3. The positive 5 gives me a positive 10x. This gives me a negative 6x. And 10x minus 6x is positive 4x. And of course, these multiply to that. So this tells me that x cannot be equal to 0. So I have all the values of x such that x cannot be equal to 0. This tells me a negative 5 over 2. And this tells me a positive 3 over 2. Okay, I'm going to cancel common factors from the top and bottom. So I'm going to start by canceling this. And then I'm also going to cancel 3 of these x's with 3 of those, making that an x to the 1. Everything canceled out on top, but so I have to write a 1 up there. And then everything but an x canceled out on the bottom. So that's the final answer. Okay, I'm going to cancel out common factors here. So I'm going to cancel this and this. And I'm going to cancel out one of these x's with one of those, making that a 4. 5 minus 1 is 4. So the bottom completely canceled out, and so it's a 1, but you don't write any fractions over 1. It just disappears. So we just have the top. So this is going to be x to the 4 times 2x minus 1. So if it cancels out in the top, you have to write the 1. But if it cancels out in the bottom, don't write it at all. Here I'm going to cancel the common 3x plus 2. And we're going to end up with x minus 3 over x minus 6. Do not put the parentheses, because this fraction bar implies parentheses around everything on top and everything on the bottom. So putting the parentheses would be redundant and unsimplified. So this is our simplified answer. Here I'm going to cancel the common 2x minus 3. I'm also going to cancel 7 goes into this 3 times and into this 4 times. And I'm going to cancel all 3 of these x cubes with 3 of those, making that an x to the 1. So on top, I'm left with 3 parentheses x plus 5. On the bottom, we end up with 4x times x plus 10. Don't try to cancel this 5 and 10, because those are terms, and terms cannot be canceled. Okay. Notice that this is a binomial around 2x minus 3, but this is 3 minus 2x. These are opposites of each other. They can just cancel each other as long as you pop on a negative. So this is negative 1. You do need a number, so this cancels to 1 with a negative there. Again, I'm going to do the same thing. Here we have opposite. This is a 7 minus 2x and a 2x minus 7. They're backward around a negative, so we can cancel these out as long as we pop on a negative. So my final answer is negative for the whole fraction. And then remember, these parentheses don't get written out because they would be redundant. So on top I have 3x minus 5. On the bottom I have x plus 1. Be careful that the negative is out in front of the entire fraction. Don't capture it above the fraction. Okay, I'm going to factor both of these. So the top factors is x plus 4 times x plus 5. The bottom cancel factors is x plus 4 times x minus 3. And then I'm going to cancel this common factor from top to bottom, and we're left with x plus 5 over x minus 3. Okay, I'm going to factor both the top and bottom. The top is, let's see, x minus 7 times x plus 2. The bottom will be x plus 6x plus 2. And then we're going to cancel this common factor of x plus 2. And we're left with x minus 7 over x plus 6. I'm going to factor these. Factor these in any way that you want. I'm not going to use the grouping method because I think it's too time consuming. But I'm going to... Here, look, when I'll do the bottom first because I think it's easier, and that's going to give me hints on how to do the top. So I'll put 5 and 2 here so that I have 5 on the inside and 4 on the outside, which will give me a difference of 1. So I need a negative 5 here and a positive 2. That gives me a negative 5 on the inside, a positive 4 on the outside, and that gives me negative 1. So when I factor this, I'm going to try and see if 2x minus 5 is one of the factors so I can see if it cancels. And that makes this 2x, and this would have to be a plus 3 just because I know that this times this would have to equal this. And let's just make sure the middle term works. The outer is positive 6. Wait a minute. This is not positive 3. This is negative 3. Okay, let's try that again. So the outer is negative 6, the inner is negative 10, and that does give us that. And this times this is our positive 15. This times this is our positive 4. So that does work. And again, I kind of was clued into that because I had a 2x minus 5 on the bottom. So I was able to kind of guess that that was going to be one of the factors up there. Anyway, my final answer is 2x minus 3 over x plus 2. So now I'm going to factor this. So on the bottom, we're going to have x plus 8, x minus 2. And on the top, we have 2 minus x times x plus 5. These are backward around a negative, so we can cancel these out as long as we add a negative sign. So our final answer is negative x plus 5 over x plus 8. Okay, Because this is multiplication, any factor on top can be canceled with any factor on the bottom. So I'm going to start canceling. This cancels with this. Let's see. X plus 4 cancels. And we have 3x minus 2 cancels. And our only factors left are right there. So we have 3x plus 5 over x plus 1. Again, this is multiplication, so anything on top cancels with anything on the bottom. So I'm going to start with 4x plus 5. I'll move on to 2x minus 1. And this and this are opposites. So I can cancel these as long as I pop on a negative in front of everything. So now the only factors left are 2x plus 1 and x plus 1. And don't forget the negative. So I have negative 2x plus 1 on top and x plus 1 on the bottom. Okay, this is a division, so this has got to be flipped upside down. But I'm going to cancel within each fraction first so I don't have to write so much when I start flipping things. So this cancels with this, and actually that's it. So now I'm going to start, I'll rewrite this. I'll have x minus 3 over 2x plus 7. This turns into a times, and I'll flip this upside down. So I'll have 2x plus 7 times 2x minus 1 over x plus 8 times x minus 3. And then I'll cancel. X minus 3 cancels there, and 2x plus 7 cancels there. And we're left with the only factor, 2x minus 1 over x plus 8. This is a division, so this is going to have to get flipped upside down. So first I'm going to cancel that because I can within that fraction. And I'll have 4x minus 3 over x minus 1. This turns into a times. When I flip this upside down, I've got x minus 2 times x minus 1 over 3 minus 4x over x plus 8. And then I'm going to start canceling. X minus 1 cancels here. These are opposites. It cancels as long as you pop on a negative. And then we just have this over this. So our final answer is negative x minus 2 over x plus 8. Okay, I'm going to factor all 4 of these things. So factoring this gives me x plus 7, x plus 2. Factoring this gives me x minus 6, x plus 2, times, factoring this gives me x minus 6 times x minus 4, and factoring this gives me x plus 7 times x plus 5. Now, anything on top can be canceled with anything on the bottom. So I'll start by canceling the x plus 7s. Then I'll cancel x plus 2s. Then I'll cancel x minus 6. And the only factors I'm left with are right here. X minus 4 over x plus 5. Okay, I'm going to factor everything, and I'm going to change this to a multiplication and flip this upside down while I do this. So when I factor this, we've got x minus 4 times x minus 3. When I factor this, I've got x minus 7 times x minus 3. I'll change this to a multiplication, and I'm going to factor this but put it on top. So this is x plus 7, x plus 4. And this I'll put on the bottom here is x minus 5, x minus 4. So now I'm going to start canceling. X minus 4 cancels here. X minus 3 cancels here. And oh, wait a minute, I made a mistake here. This should have been an x plus 7, x minus 3. I made a mistake there because it needs to multiply to a negative 21 and add to a positive 4. So my outer is negative 3, the inner is positive 7. Sorry about that if that bothered you earlier. And that cancels there. So now the only factors I have left are this and this. So I have x plus 4 over x minus 5. Okay, so we have a rectangular garden, so I'm just going to draw that. Here's my rectangular garden. And the length is 5 feet less than twice the width. So I'll call this, I'll call it W. You could call it X, whatever you want. But this then would be 2W minus 5. That's 5 feet less than twice that. The area is 88. Now, the rectangle, the formula is the width times the length is equal to the area. So I'll distribute this, and I'll get 2W squared minus 5W equals 88. This is a quadratic equation. Quadratic equations need to be made equal to 0. So I got to move that over. So I have 2W squared minus 5W minus 88 is equal to 0. So I'll factor this. Now, I'm going to try 11 and 8. If I do an 11 here and an 8 here, what that gives me is 16 on the outside and 11 on the inside. 16 and 11 do give me the difference of 5. I need to put the negative here and the positive here, so that it gives me negative 16 and positive 11 to give me negative 5. So this has W equals negative 11 over 2 and positive 8. Well, a physical dimension could get as small as 0, and meaning it's dimensionless, but it can't get negative. It doesn't make sense to do that. So this gets thrown out, is impossible. And then, if W is equal to 8, 2W minus 5 is this. 2 times this is 16 minus 5 is 11. So, and these are in feet. So the dimensions are 8 feet by 11 feet. Okay, I need to solve this. This is a quadratic equation, so I need to start by making it equal to 0. So I got to move that over. So I have 4x squared minus 11x minus 3 equals 0. So I'll try 4 and 1. So, and the only reason I'm trying that is because this is such a big number. So I have 4x and x. And if I put the negative 3 here, that gives me negative 12 on the outside. And a positive 1 gives me a positive 1 on the inside. Negative 12 and positive 1 really do add up to that. So this gives me x is equal to negative 1/4 and positive 3. So here we have a quadratic equation, so I need to set it equal to 0, so I got to move my 16 over. Again, I'm going to try 4 and 1. And that's not going to do it. 5 and 3. Nope, that's not going to do it. I can tell that 4 and 1 is not going to work. So let's try 2 and 2. So now let's try 5 and 3. Minus 5 minus 3. Now, this is going to work because on the outside I have negative 10. On the inside I have negative 6. And negative 10 minus 6 is negative 16. So this tells me it's positive 3 over 2. And this tells me positive 5 over 2. Okay, this is a quadratic equation. And it needs to be equal to 0. So I got to move the 3 over to start. I'll try 4x and 2x. So I might have to go back and do 8 and 1, but I think it's going to be 4 and 2. So if I put the 3 here and the 1 here, nope, that's not going to do it. What if I did it the other way around? If I put the 3 here and the 1 here, that's not going to do it either. So this must be an 8 and 1. So I was wrong, and let's try 8 and 1. So if I put the 3 here and the 1 here, that gives me 8 on the outside and 3 on the inside. 8 and 3 give me a difference of 5. I need to put this as a negative and a positive here because I need negative 8 on the outside and positive 3 on the inside to give me the negative 5. So this tells me x is equal to negative 3 over 8 and positive 1. Negative 3 over 8 and positive 1. This is a quadratic equation, so I need to solve it by setting it equal to 0. So I'll move that over. This time I'll try 4 and 2 again. And if I put a positive 3 here, that's going to give me a positive 12 on the outside, and I'm trying to get to negative 3. So I need a negative 1 here, and that's going to give me a negative 2 on the inside. Positive 12 and negative 2 really do give me that. So this gives me a solution of positive 1 over 4, and this gives me a solution of negative 3 over 2.